Today we'll be talking about problems 15 and 16 in the senior section of the Sample 2 IMONST paper. So problem 15, there are 99 students, call them student 1, 2 and so on, and then 99 seats around a round table. How many ways are there to arrange the seating of all the students so that for any two neighboring students, their numbers differ by at most 2? So 99 is a very big number in this aspect because it's quite daunting. So let's pick a number. So maybe I say a random number. So maybe say 23. So if I say the people who sit by them, they have the seat number. The numbers differ by at most 2. So we know that 21, 22, and then 24, 25. So only these 4 people can sit beside 23. So this is the analogy we'll be using. And then around this round table, we will be assuming that the 99 chairs are the same. So it's not like, oh, this one is a wooden chair, this one is a wooden chair, and then this one is a steel chair. No. Okay. So if you rotate, it will yield the same outcome. So I will count that as the same. But if you flip it, that's a different story. So how did I solve this problem? So if we pick a number between 1 and 99, any number, maybe somewhere in the middle, maybe 44, 45, something like that, you can't actually tell which are the people sitting beside them because you have 4 possibilities. So what we'll do is we'll start with maybe the largest and the smallest numbers, okay, so that you are left with no choice. Okay, so for student 1, so for 1, the numbers that differ by them by at most 2, we only have 2 and 3. And then for 99, the numbers that differ by at most 2, we only have 98 and 97. So it's very obvious that the people who are sitting by student 1 will only be student 2 and student 3. And then this one will be 98, 97, but I won't explain further first. Let me erase this because in order to avoid confusion. I think this video will be shorter than yesterday's one. So now looking from the perspective of student 2, since we have a student 1 beside him, and then the numbers that differ by most 2 for 2 will be 1, 3, and 4. So 1 and 3 are taken, so we only can put 4 over here. And then for student 3, the numbers that differ by at most 2 from 3 will be 1, 2, 4, and 5. And then 1, 2, 4 are taken, so we only have 5. So using this same analogy, we repeat it. So for 4, we will have 2, 3, and then 5, 6. But we have 2, 3, and 5 taken, so this one is 6, and then this one will be 7, 8, 9, all the way up to 98, and then 99, 97 over here. So actually, we only have this one configuration. But if we flip it, so I write flip. I don't know why I'm writing a chemistry equation like thing over here, but very strange. Okay, so if we write 1 and then we put 3 to the left of student 1, and then we put student 2 to the right of student 1. So now what we have is the same thing, the same analogy are repeatedly used. Okay, so something like that, and then we have 99 over here, and then 98 over here. So yeah, these are the only 2 possibilities, and so the answer to problem 15 is 2. I hope you got it right. I don't know if I got it right because I haven't checked with anybody yet. So yeah, okay. And now we'll be talking about problem 16. So the number, you see, I already draw before this line. 2a 9b is equals to, okay, it's a product of 2 integers, 2 to the power of a and then 9 to the power of b. How many different values of a plus b are there? So if we want to do this problem, let's set some boundaries. So what is the maximum value of b that b can have? So maybe say, okay, let's see, 9 to the power because 9 is significantly bigger than 2, so I'll use 9 as the example. 9 to the power of 0 is 1, 9 to the power of 1 is 9, 9 to the power of 2 is 81, 9 to the power of 3 is 729, and then 9 to the power of 4 is 6561. So which is obviously bigger than 3000, which is 3000 is bigger than our 2a9b lah, okay? So for b, the maximum value for b would be 3. Okay, Then let me erase some things to make some space. Wow, this video is way much shorter than the one yesterday. Wow, I started a lot in yesterday's video, I found out. So the maximum value for B, so B max will be 3. So we can just divide this into 4 cases because there aren't that many. So let's say B equals 0, and then B equals 1, B equals 2, and then B equals 3. So what we have over here is that if we have, say, 2a90, which is, we will have 2 to the power of a times 1, okay? And then now I'll need to add in some additional information. So for 2 to the power of a, the units digit will have possible values 2, 4, 6, 8, never 0, because you need to multiply by 5 to get a 0, okay? So 2, 4, so actually the pattern is 2, 4, 8, 6, 2, 4, x 6, okay? 2, 4, x 6, 2, 4, x 6. And then for powers of 9, the units digit will have values of 9, and then 1, and then 9, and then 1, and so on and so forth. So 2a90 equals to 2 to the power of a, but we don't have a 0 as the last digit of a power of 2, so this is rejected. And then for if b equals to 1, this one is actually more absurd. It means that 2 to the power of a times 9 is, it means that 2 to the power of a times 9 would have 2a91. But if we divide by 9, this means that 2 to the power of a is an odd number. So which is more absurd because 2 itself is an even number times even number will only yield even numbers. So this one is also rejected, which is very strange. And then b equals to 2. This one sounds more interesting. So this one is 2 to the power of a times 81. Okay, so if we want to set some boundaries, so the smallest multiple of 81, which is larger than 2000, so maybe 2a92 is smaller or equal to then, larger or equal to then, and then smaller and equal to then. This one will give us what is that? 25 times 81 equals to 2025, and then the largest multiple of 81 smaller than 3000 would be 37 times 81 is 2997. And then there actually is a value for this number, which is very coincidental. So actually here, if we divide by 81, we know that 2a92. If we divide by 81, we know that the last digit will be 2. So between 25 and 37 is 32. 32 times 81 is actually 2592. So 2 to the power of 5 is actually 32. So this is one answer for our a plus a and b. So a and b can have a possible value of 5 and 2. So for here we have 5 and 2 for a and b. Okay, so if our b here is equal to 3, so 2a93, this one will mean that 2 to the power of a times 7 to 9 is a multiple of, is 2000 plus. But this also means that 2a is odd, so again rejected. Okay, so we cannot have this. So the only possible value is 5, 2, a being 5 and b being 2. And then how many different values of a plus b are there? So because we only have how many different values? Because we only have our 5 and 2. So there's only 1 as our answer. So yeah, I need to erase some things because I need to jot down all the answers over here. Okay, so our answer to problem 16 will be 1. And yeah, this is the video for today, which is comparatively shorter compared to yesterday. So I'll be making videos. Actually, I'm making all these videos on the same day lah. But you guys already get it lah. I just publish one every single day. Okay, so in the next video, we'll be talking about problem 17 and 18. And then for the finale, we'll have problems 19 and 20, which will take maybe 20 minutes. I'm not sure. So that's all for today, and bye-bye.